you're a petroleum operator, you know the oil and gas industry is changing fast. You've got to adapt to the future by creating greater efficiency in operations, reducing risk, and designing for a more sustainable future. You also know everything in energy happens somewhere. And since getting location right is so important, turning to Esri gives you the power you need to stay ahead. You get the most advanced capabilities in the industry, from the world leader in location technology. With our integrated GIS platform and huge partner network, you have access to groundbreaking solutions and a complete GIS enterprise system. Network management tools with True 3D let you visualize your system the way it looks in the real world and bring your design to life to model and manage emerging renewables. Spatial Tools give you a better understanding of your network and assets. Mobile field apps streamline data collection, routing, and navigation. When natural disasters strike, you get real-time monitoring of operations to reduce risks, speed up recovery, and get back to business faster. And you can create a true digital twin of your network to show connections that match the real world. Plus, an open architecture lets you share maps and apps on any device, any system, anywhere, anytime. And with cutting-edge spatial analytics, you can leverage IoT, artificial intelligence, and machine learning to understand the past better and forecast the future more accurately. With Esri location technology, you'll have everything you need to supercharge operational efficiency and diversify to meet growing demands of the future.
Hello, everybody, and welcome to the operations session for supporting field efficiency for the 2021 Petroleum GIS User Conference. My name is Adam Pittman, and I am excited to serve as your guide today as we walk through the operations session for the next 90 minutes. We are streaming live right now, and if some of you are having some streaming glitches, I do want to remind you that there is a settings option in the lower right corner of your viewing window. And if you're having some problems, you can go in there right now and change your setting to 720. And that should help out quite a bit with your stream. So I'll remind you here shortly again in a little bit. But we have some fantastic success stories to share with you today. And we're privileged to have three featured guests joining us. We have Ryan Rudzik of Tet Barnett, who's going to talk about how they are using some novel and innovative ways to have visualizations improve how they're running their operations. We have Tenson Rubling and Morgan Titus of Repsol, who will be joining us to talk about the rapid digitalization of operations out of Repsol. We also have Scott Newless from our natural resources team. Scott is a solution engineer, and he's going to be showcasing some new technologies that we feel are making a big impact in the operations space. And lastly, we have Casey Srivinka and Carlos Sosa of Apache Corporation talking about how they are capitalizing on value-directed operations. We will be conducting an open question and answer session. I'm joined by all of our presenters right now. We're all on the meeting invite, and we are calling in from three of us in Houston, one in Fort Worth, and of course, Tenson and Morgan are in Calgary. So if you have questions along the way as they cover their presentations, please enter your question in the comment box. So here's a depiction on the right-hand corner of this slide that shows you where you should be seeing your ability to ask a question. It would be a big help to us if when you do ask your question, go ahead and type in the name of the presenter and then the question that you're asking. So for example, if you had a question for me, you might start with my name and then the question. That way, all the team that's moderating and helping us out, they can actually send the questions to us throughout the session. We're going to do our best to answer all of your questions live at the end of this session. So I'm joined, like I said, by all of our presenters. Please don't be shy, ask your questions. So as we get started, I'd like to kind of do a lead in for what we're going to be talking about. You don't need me to tell you that it has been a difficult year, a difficult year for operations, a difficult year for working at home, where most of us are broadcasting live from. But I'd like to set the context for the trends that you're going to see in this presentation. There's some pretty exciting things that you're going to hear about. And one of the things I think you may understand is that oftentimes when you have difficult times, these tend to serve, at least from a technology perspective, as a catalyst for change. And that's absolutely a trend that you're going to see through all of the presentations today. Again, I do want to remind you, if the broadcast is coming across a little bit choppy for you, please go down to the settings window at the bottom right corner, and you can make an adjustment to 720 for the resolution, and that should help out significantly. So as we get into this, I'd like you to think about some ways in which we target efficient and safe operations. And like I said already, challenging times are certainly rapidly accelerating the digitalization of our operations, so that we are operating not only more safely, but we're going to be more productive across the board. So when you think about those, you're oftentimes asked to fall within one of these four categories, if not all of them. So this is not anything new to you. So how do we help you hit the mark here? You're asked by your business and your business leaders to reduce risk for safety, health, environment, and risk to your business financially. You're also expected to do more with less in a reduced footprint. Of course, cost is there, maximizing your current investments so that you can operate as efficiently as possible. And last, but certainly not least, it's increasing productivity, being as productive, if not more productive, with less resources. And of course, we always have ways that we can leverage technology to help us be more productive. These are the four themes that you're going to see today during our operations session. And you're going to hear from your peers in the industry how they are responding to this dynamic situation and how they are capitalizing in these four key areas to hit the mark. I think there's good news here. All of you that are joining us from around the world, we absolutely thank you for joining. And this is just the point of our gathering, is to bring GIS professionals in petroleum operations from around the world to discuss the challenges that we're facing and to understand how you, as the game changers, can make an impact across your business. And the great news is that as you look at this graphic here, you control that target. You can move the target and you can hit the mark with the general capabilities that you have available. In fact, the capabilities that you're well aware and have been doing for quite a while. You have amazing capabilities and tools to integrate your systems of records so that you can use your valuable information and better manage the data that you have at your hand. And today, we have more data available than ever before. Let's not forget cartography and the mapping capabilities. It's easy to overlook what you may think is simple, but we're going to see a great story here in a bit on how mapping and cartography can make a huge impact to how your business operates. Of course, spatial analysis, that's our bread and butter. Now we're incorporating some really amazing technology with data science and open science platforms to leverage and integrate even more than we have ever had before. Imagery and remote sensing has been a huge advantage to us, and the capabilities with imagery and remote sensing are advancing weekly. And it's something that we spend quite a bit of time working with all of you on. Real-time visualization, we'll see some examples of that today, but being able to ingest your sensor information, not only for visualization, but for real-time analysis. It's possible and it's easier than you think today. And then lastly, using configurable applications to rapidly deploy digital solutions into fields. Many of you still have, and your operations and businesses are still operating with paper-driven workflows. There's a rapid shift now for digitalization, and that is a movement that we are seeing like never before. Again, you'll see examples of that here shortly. One of the trends that we're seeing is that the petroleum industry is very interested in leveraging the best-in-class scenarios from other industries. For example, let's take a look at transportation management and analytics. We are now connecting our petroleum customers with customers that do this for their primary business revenue, right? Meeting with the folks that do logistics and logistics operation on a daily basis and learning from them how best to apply workflows and translate those into the things that we do in the petroleum industry every day. Some of those might be looking at real-time information, doing analysis and understanding the driving patterns of your field operations crews to reduce accidents, to improve efficiencies. Looking at operations and how folks move around the field is something that is happening on a daily basis. We're also taking a look at what the great work from our architectural, engineering, and construction firms. Many of the things that you see from that AEC space are starting to fill the foundation of what you all are working on as digital twin efforts. Understanding how to model CAD and engineering diagrams, incorporate real-time information, and visualize with reality capture your operations so that you can operate more effectively and efficiently. This is happening right now. And there's some exciting technologies that are advancing on the Esri front that are going to help with this. And you're going to see this pattern grow and grow and grow. Also, the work that's happening with our public safety and national security customers. The great work that they are doing is finding its way into helping you improve your operations across the globe and help you make your operations safer as you understand with greater awareness how other impacts can impact your operations. And lastly, our work with imagery and remote sensing is significant, and we are seeing cross-industry efforts and best practices now bleed and work their way into the petroleum space, specifically in the natural resources space with agriculture and forestry. And some of the practices that they're doing there actually finding their way into petroleum workflows to help with detection, automation, capturing features from imagery, and doing all sorts of remote sensing efforts and boundary mapping. So very interesting work that's happening with imagery and remote sensing. You're doing these things, and you as GIS professionals are providing this process and this framework for applying all the things that you know and are trained to do. And you're actually working through measurement, data management, visualization and mapping, analysis and modeling and planning and design. And you're doing those 4 key things, which you're going to hear about today, all to make better decisions faster so that your business leaders can take action and actually make decisions that are going to impact and help you and your operations operate safely and more effectively. Now, I need to do a segue for our first guest presenter. And I'm going to set the stage for them by talking about some of the work that we're doing in mapping and cartography. Of course, this is our bread and butter. Everybody that is watching this broadcast right now is here because you use maps to communicate. All the work that we do has a location coordinate to it. Everything is location-based. And we use location, of course, to communicate. Our medium for doing that is maps. We're constantly working on improving the way we can support the work that you do with mapping and cartography. But sometimes you just need that little extra something special. And this is where I'm going to introduce Ryan Rudzik of TEP Barnett, where Ryan is going to walk us through a novel way that he's used visualizations to improve his operational efficiency. Ryan?
My name is Ryan Rudzik. I work for TEP Barnett. We're an affiliate of Total. We operate more than 2,000 wells in the Barnett Shale in a highly urbanized environment. I'm here today to share our production web map, along with a novel solution that we came up for visualizing production over time. It's built using FME and ArcGIS Enterprise. Our production web map application contains some common elements familiar to many people in our industry. We display things like field route polygons, wellbore symbolized by artificial lift type, daily gas bubble volumes, daily water bubble volumes, daily line pressure bubble volumes, and gas to liquid ratio bubbles. A very unique feature of our production web map application is what we call circular charts, which are rendered using an FME process that I developed. Their appearance is inspired by chart recorders, which are machines with paper charts that rotate over time. They have mechanical armatures that hold pens that move across the paper based on the sensor or meter readings. Constructing our circular charts required only two basic data sets. We have a well bottom hole point feature class from our geodatabase, and we have daily production history tables with gas, water, and line pressure. FME was the right tool for transforming the raw data into circular charts. Each chart represents 365 days of production history for every TEP well that produced in the past year. FME exports these features as simple polyline and polygon feature classes to our geodatabase. It takes about 40 minutes each night to rewrite the data set. These are the basic steps in FME to produce our circular charts. We start in step 1 with a well bottom hole location. In step 2, we merge our well location and our daily production using a unique identifier. Step 3, the FME offsetter uses polar coordinates to plot daily volumes. Step 4, the FME bufferer offsets grid lines for every 500 ground units. Step 5, the FME line builder constructs the time divisions at the first of every month. In step 6, the FME point connector turns our plotted points into polygons. And then in step 7, the FME line on area overlayer intersects all of our geometries and keeps only the lines that overlap the polygons. There is no circle chart transformer in FME. I had to think in simpler terms and use standard transformers for basic geometry manipulation, plus some math. There's two basic concepts that were necessary to render these charts. Polar coordinates were used to plot the daily values in the charts. They require 3 variables: origin, angle, and offset. The origin used the bottom hole location. The angle was translated from the production date, day interval. The offset was the production volume used as distances in ground units. But before I could do any geometry operations, I had to do some data scaling. We used min-max normalization. Scaling was necessary to make the overall size of the charts more practical, given the typical well offsets in the Barnett Shell. ArcGIS Desktop was used to design the final visualization and the appearance of the circular charts. This is where I designed the symbology. Scale dependencies were applied to the geometry and the labeling to optimize the display performance and visual clarity. Scale dependencies provide the user with no more detail than what was practical at any given scale. The resulting visual was published to ArcGIS server for use in Portal. This is a gallery of our circular charts. As you can see, there are many varied results. In some of these displays, you can clearly see recently recompleted wells. You can see inconsistent production results. You can see where there's been steep production declines or where weather or operational events have occurred. This is a live view of our production web map. Initially, what the user sees is the bubble map. Right now, we're seeing the daily gas volume bubbles for the most recent day's production. As a user zooms into the locations, you can start to see more detail. We have labels turning on that are giving to the most recent day's gas production. As we get a little bit closer, you'll see that it switches over to the circular chart representation. you start to see a simple profile of the circular charts. As we get a little bit closer, it turns on more detail. Another step closer, and you start to see the grid lines for the circular charts. And then closer yet, and it turns on labels representing the volumes and the time declinations of the charts. In the center of the chart, you can see the most recent days, gas production, water production, and line pressure. In this example, you're seeing a few wells that were recently recompleted. So they were offline for a portion of the year. They came on very strong, and you can see a steep decline, which is pretty typical when a well is brought back on. Looking at another example, we can see a group of wells that have had sporadic results over the past year. Those are potential candidates for workovers. Looking at another area, we can see a couple of wells that have had fairly consistent results over the past year. Something that stands out, you all recall the weather event that we had this spring in Texas, and it caused a lot of problems for a lot of operators, and it's clearly marked on these charts. You can see that they both have this drop-off in production and this increase in line pressure as a result of that event. So, results and lessons learned. Users want to understand production spatially. Spreadsheets and standard bar and line charts are not always enough. Some of the things that our production web map application helps users with are weather events and why they affect some wells more than they affect others, or production impact from pipeline maintenance. Well communication, where water or gas migrates to a location next to it after it drops from another well, and understanding production decline over time. It also helps identifying good candidates for workover operations. Users want to understand production spatially. Spreadsheet and standard bar and line charts are not always enough. Our production web map is used daily and has been very beneficial to users from our operations and reservoir groups. Some of the things that our production web map application helps us understand are things like it quickly allows a correlation between a dip in production and an increase in line pressure to be correlated without the need to drill down. Production impact from pipeline maintenance like pigging operations. Well communication, where water or gas migrates to a location next to it after it drops from another well. And with understanding production decline over time. It also helps in identifying good candidates for future workover operations. Thank you for your time and for watching my presentation. I look forward to answering your questions at the end of the session.
Thank you very much, Brian. That was absolutely one of the most effective and creative ways that I have seen anybody visualize production information. And I'm sure you're going to have quite a bit of questions on that at the live question and answer here pretty soon. But, looking back at your presentation, some of the things that I really took away from it was that, making a big impact can be, and I say in quotes, a simple solution by simply changing the way that you visualize the information that you're trying to communicate. And that's absolutely what you did with those beautiful polar charts for the well production. So great looking application. And what I think you also did really well was determined how you could leverage the technology. In this case, you used quite a bit of work in FME to funnel that into ArcGIS and actually use a web application to communicate that. And then lastly, you had a good understanding of the problem that you were trying to solve and the problem that your peers at Tech Barnett were struggling with, and you came up with a creative solution, and you brought your expertise to the table to help them solve a problem. So really interesting visualization, and I'm really glad that we start off our sessions today with starting with visualization, mapping, and cartography, and helping helping our business folks actually make heads or tails of what they're trying to do. But we all know that you can have beautiful maps, but the work that you're doing from an operational standpoint is far more than dots on a map. The operations that you support are complex, and they go across many different areas. Many of us have maps that look just like the map you're seeing depicted here within your organization. It's a pretty common map. There's health and safety. There is operational information from SCADA systems coming in. You're trying to gather greater return, lower cost, smaller footprint, all from an unbelievable amount of information. But I'll say that chances are pretty good that although this map looks great, this map may not help your business leaders or the decision makers within your organization conduct their business in a more efficient or effective or safe way. So there's a lot of things that we need to bring to the table when we think about this. And I'll start off with what I'm calling the wheel of benefits. And some of you would have seen things like this before. These go back to those 4 principles that we started our presentation with. All of you are here as GIS professionals, as IT professionals, and you're supporting customers, right? Just like we support you as our customers, you have your customers within your organization, and you're trying to have happy and successful customers by giving them applications that improve the quality of work that they're doing, make the work that they're doing a little bit easier, and you're expected to actually hit all the points around this wheel. Why do it if you're not improving the quality or increasing the efficiency of an existing tried and true process or minimizing risk across a number of factors? You're expected to use this technology to operate smarter for you, not have you work harder, right? So you need to increase productivity, increase capacity of the folks that you serve, the customers that you're supporting. And I cannot leave finance out, because that is, at the end of the day, you're expected to lower costs and raise revenue, but at the same time, increase your operational capacity, increase your health and safety, and all the other factors that you put first and foremost for your operational efficiency. This next presenter did a very good job of working through all of these things that we have just described. So whenever you think about this, and if there's anything that you take away from today, think about how you can better understand the business problems that you're trying to solve and how you can work with your peers in your organizations to provide a better plan and act on those plans by understanding the business needs, working with your executive sponsors, your business champions to work through preparing, implementing, operating, reviewing, and then revisiting that whole cycle over again. You're going to be successful, and you'll probably be successful a little faster than you would if you had not understood that. Because really, you're on this, you're using this giant roadmap to try to figure out how you're going to improve your operational efficiency. And you certainly, all of you are going to be leaning on spatial technology to drive that value. And there's a lot of things that you have to consider. Of course, we've talked about productivity already, smaller footprints, increased efficiencies, et cetera. Tenson just described those concerns, but you're also looking to do things like drop the dashboard time or have your folks move around the field in a more efficient, faster manner. And you saw that in Morgan's web application, so reducing operating cost. And of course, safety is key. Got to operate with safety in mind and actually improve the safety performance. But increasingly, companies are concerned about emissions and reducing carbon footprints, which is something that you've got to measure and you got to quantify, and those are working their way into operational efficiencies as well. So what you saw the start of in Morgan and Tenson's presentation was how to better plan and bring visibility into operations. And in their case, they did a rapid digitalization from a paper workflow to an operations command and control center with dashboards and applications and real-time information and tools that help those folks do their work better. So you're on a journey, absolutely, and I would call it a roadmap. Now at Esri, we are doing our best to help support you with those and make it easier for you. You saw examples along the way of configurable applications in use to deliver results. You've seen dashboards. You saw the screenshot of the ArcGIS dashboards that are used to visualize that real-time information and start to track the key performance indicators. So these are constantly evolving, constantly changing, and visualizing your operational intelligence is not a hard thing to achieve with a dashboard. And many of you are using dashboards to great success. Not only are you using dashboards on traditional views, like on screens and laptops and traditional monitor environments, but you're using them on mobile devices as well. So you're increasing visibility into your operations. And there's all kinds of things that we're doing at Esri to continuously enhance and increase your situational awareness on any device, anywhere, and certainly anytime. One of the biggest gains that we're doing, and it absolutely forms the foundation of the information that you want to see in a dashboard, is real-time visualization. Now, we've been doing this for a long time, and every year we have someone that shows some great work they're doing with real-time information, be it vessels, trucks, SCADA information, tracking information off of mobile devices, you name it. And you've been doing these things. But we've come out with some new technology recently, and you're going to see that here in a little bit. But that's Arcgis Velocity. So you continue to work within your enterprise environment with technologies like GeoEvent Server, bringing in that real-time information and performing some analytics. What Velocity does, and does very well, is it serves as a SaaS solution backed by Kubernetes that allows you not only to ingest that information, but maybe more importantly, perform real-time analytics on that information. And there's many different types of analytics that you can perform, but that is a real difference maker. So not only integrating your sensor information, bringing in all of your IoT feeds, but you're actually able to, in near real time, perform analysis to help you operate more effectively and more efficiently in the work that you're doing. You'll see a demonstration in just a bit, but before I hand that over, let's talk about some of the ways that you actually get that information into Velocity, right? We've got a whole suite of applications, ready to use applications that support an array of field work. And the whole life cycle really of field work, from everything from planning to navigation and routing to capture to visualization and on to location tracking. All of those things are supported right now by a suite of Esri applications. Many of you are using these applications and have been for quite a while. Well, at Esri, our development team has been quite busy trying to take all the comments and the feedback that you provide over the years and enhance and provide more streamlined applications that help you combine some of the things that you're doing into a single application. And that's ArcGIS Field Maps. It's a new application. It was recently released. You have access to it right now. And if you are using a field user type, for example, you can download that right now, sign in with your account, and off you go. You can do tracking, you can do data capture, you can do visualization, you can do it all. So it is a pretty fantastic application, and this is a wonderful time for me to stop talking and have my good friend Scott Newless join us and talk about how we can not only view information, do markup, data collection, asset inspection, but more importantly, bring in that tracking component that you now have built into Field Maps, funnel that into Velocity to do some near real-time analytics and see some great information that you wouldn't be able to see otherwise. Scott, you ready to take it away?
Thank you, Adam. Location plays a crucial role in many aspects of operations. ArcGIS supports all phases of field operations through targeted mobile apps that leverage the power of location. These apps deliver key capabilities that enable field workers with the tools they need to do their job efficiently and effectively. These capabilities include work tasking, navigation, map visualization and markup, data collection, and more. Location tracking is another built-in capability of ArcGIS, and this is the one we're going to primarily focus on today. Location tracking adds value to operations. Field staff are always on the move, performing maintenance tasks, inspecting assets, and carrying out other activities. For workers, location tracking promotes productivity in the field through maps that show where they are and where they've been. For organizations, location tracking provides visibility into where workers are at all times, making it easier to plan work and respond to unplanned events. It also provides increased understanding of where workers have been, making it easy to verify locations that were visited and discover areas that may have been missed. The insight gained through the analysis of location tracks enables collaboration and coordination across the organization. Location tracking also helps drive operational efficiency. Worker locations can be shared in real time to provide organizations with enhanced situational awareness and decision support. Collected tracks can be analyzed in near real time or over time to determine where workers traveled and when they were there. Results can be used to verify proof of work and measure level of service against expectations. As organizations adopt more of a management by exception approach, location tracking can be used to better allocate resources as they are needed. Location tracking leverages the devices, smartphones and tablets, that field workers carry around with them on a daily basis. Workers simply enable location tracking to start recording their location. In connected environments, the data is synced and shared with others that have been granted access. In disconnected environments, location data is stored on the device until it can be synced. All location data is stored in a secure and standardized format that can be used for visualization and analysis in ArcGIS. As I mentioned earlier, location tracking is a built-in capability of ArcGIS field maps, Esri's premier mobile application. This allows workers to visualize their tracks on interactive digital maps alongside other operational and reference layers. Location tracking is also now included for all field worker user types, making it even easier to get started. Let's take a quick look at the location tracking experience in field maps. Location tracking can be enabled directly from the home screen. I have the option to track for a specific duration of time or until I manually disable. When I open a map, I see my current location along with any other layers that have been added to the map. I can also enable and disable tracking from the GPS details menu. Toggling on my tracks in the layer list will add my historical tracks to the map as well. Here's what a live example of location tracking looks like. As I drive down the road, my tracks are being recorded and automatically added to the map so I can see where I've been. Tracks will continually be collected until I manually disable location tracking or until my set duration ends. Location tracking by itself offers a variety of benefits, but one of the best ways to extend its value is with analytics. Analytics can transform raw location track data into usable information and actionable intelligence. Arcgis Velocity has the ability to ingest high-frequency, high-volume data and perform real-time, near real-time, and over-time analysis on that data. This makes it the perfect tool for working with location tracking data. Outputs can include event-triggered alerts and notifications along with dynamic layers for real-time visualization. Historical data can be analyzed to uncover hidden patterns, trends, and insights. Let's take a look at a few practical examples that leverage worker location tracking and analytics to generate actionable intelligence. The first workflow is site visit notifications. In this scenario, an operations supervisor wants to be notified when a worker arrives at or departs a well site with high H2S levels. The worker has enabled location tracking using field maps and is connected and sharing their location. In Velocity, A real-time analytic has been configured to ingest the location of the worker, determine if the location is inside or outside of the well pad geofence, determine the status of the worker, and send an email notification to the supervisor. The processing occurs in stream as location data is received, so the supervisor can pinpoint the exact time the worker arrived and departed the site. The second workflow is around level of service. In this scenario, the operations manager wants to understand the frequency at which sites are being visited to identify potential gaps in service. This layer contains the historical location tracks of all field workers over a period of several months. Looking at the raw data, it's hard to discern any specific patterns and trends. Using a big data analytic in Velocity, the data can be aggregated into bins for easier visualization. The output layer shows areas of high density in brighter colors and areas of lower density in darker colors. This data can be joined to site locations to determine which sites were visited less frequently and thus need to be prioritized for future service. The third and final workflow deals with journey management. In this scenario, a pumper wants to calculate the time and distance traveled to a job site and compare it to the travel log. The worker's location tracks indicate the path taken to and from the job site. Each track point is stylized by the direction of travel and contains a timestamp and the recorded speed. Looking at the individual points, it can be difficult to calculate travel time and distance for the entire journey. Using another big data analytic in Velocity, a path can be constructed that connects each point in space and time and calculates travel time and distance for the entire journey. The output includes a line feature with attributes for travel time and distance. This line feature represents the actual route taken by the driver, but could also be used to create a new road feature for future routing analysis. Those are just a few examples of how location tracking can bring value to your organization. Location tracking is a powerful capability that is simple to use and easy to set up. If you have a mobile workforce, I encourage you to think about how your organization can use this capability today. Thanks for listening. Back to you, Adam.
Thank you so much, Scott. There's a lot of things that happen there that I think we need to summarize. Number one, before we transitioned into Scott, we talked about how you can use the ArcGIS applications to kind of run through that whole life cycle of field operations. Everything from coordinating, planning, navigating, making sense of what it is you're gathering from the field, capturing information, and then monitoring that. You've actually seen a lot of that today in some of the demonstrations that we've had. But the real missing link now is actually doing the real-time analysis on the information that you're capturing to actually change the way you're operating in a much faster way. So we really hope that you download Field Maps if you haven't already downloaded it, and please let us know what you think. We feel that the feedback so far has been pretty good, and we certainly are expecting to hear more from you as we continue to develop and improve the work that we're doing. Some of the other takeaways, though, from the workflow that you just saw is that, like I said, you can download it. You can sign in with your named user account right now, and you have all the capabilities that Scott showed you within the Field Maps application. I'd encourage you, do some homework on Velocity. You have a blessing and a curse right now. A blessing in that you have an unbelievable and abundant amount of data to work with. The curse I would say that you have is that you have an abundant and unbelievable amount of data to work with. And so that's one of the things where Velocity shines, is actually ingesting a massive amount of information. What Scott showed was just scratching the surface, but you can bring in a lot of information and backed by Kubernetes with a SaaS environment, do some pretty amazing calculations within the Velocity environment. So I encourage all of you, I put the tagline here for maximizing your location. I think we're all just scratching the surface at all of the sensor information that we have. And I would encourage you to think of ways as geospatial professionals on how to optimize the work that you're doing and make the most of the location aspect of all the sensors you have in the field. And I include people as those sensors as well. We all carry a phone in our pocket. And in this case, that phone can tell us a lot, and you can use that information to do some pretty amazing things. So continuing to evolve our conversation, I'd like to go back and remind you a little bit about what we do at Esri, what our mission is at Esri, and our main purpose for 50 years plus has been to build tools that help you do your work better. ArcGIS is our main focus for supporting that. And our vision and the vision of our product development team and everyone at Esri is to build and provide a comprehensive geospatial platform that supports not only multiple communities and industries all over the world, but helps you to solve your problems better, faster, easier. Right, and we do that with what you were all most familiar with, which is the robust and abundant capabilities that you have within the GIS tool sets. There's extensive tools there, 2,000 plus spatial analysis tools built into ArcGIS as an example. But some of the things that you may not be as familiar with are the fact that we provide some slimmed down tools that are a version that sit on top of all of that in the form of mapping and location services and location analytics tools that you can allow others to do some pretty interesting things with. So if we move into, say, the developer community, there is a significant amount of resources that you can leverage through these sit-on-top products that allow you to build geo-enabled systems. Now, what are we really talking about? Well, all of you come from organizations where you have different communities of people, different awarenesses of what it is they understand that you do. They all, of course, understand maps. They all use maps on their phones and to navigate from their house to their favorite restaurant or whatever they may be doing. But what they may not be familiar with is how you can actually leverage location within inside the applications that they're most familiar with. So that's some of the stuff that is exciting and that we're working on, and you're going to see a demonstration of here in a little bit. But what I'm getting at is the ability to actually integrate, take the tools and all the things that we're really, really good at and that you're most familiar with, and leverage APIs, for an example, to integrate into other systems and allow those systems to do what they do good, but pull into the ArcGIS environment. And so those are some of the exciting things that we're working with at Esri. We've done that for a while through the software side, increasingly with software as service, and now with platform as a service. So you're going to see some exciting things here in a little bit. But really what's an important and critical component here is to remember that ArcGIS is by design an open platform, and that means that all the tools and all the things that we can do as GIS professionals are flexible, and it can be extended in various ways. It's interoperable using standards and direct engineering technologies to make things work. And as I describe these, some of you may be looking across the screen right now, and some of these may jump out to you. Of course, JavaScript, REST, Python, runtime environments. Those are pretty common and have been around for a while for the developer community. But towards the bottom, supporting the open architecture, as you all evolve into various forms of cloud technologies supporting your work, we're starting to see containerization and Kubernetes and Spark and Docker and all these things start to pop into here. And those are some of the things that you're anticipated and expected to support within your organization. You can do that. And ArcGIS supports those open standards, those open architectures. Some of the really exciting work is what you can do through the open science communities, right? Using things like Python and R to connect in with some of the open science ecosystem. And your communities at your organization might not realize what you can provide them. They all are trying to solve spatial problems, and they may not understand how to access the great work and the things that you can help them with. And my ask is for you to evangelize those capabilities and the things that you know you can support, and show them how they can connect in and grab that one piece and that one component to help them do their work better. Successfully integrate with the applications that they use and that they rely on to help make better decisions for your organization. So we're going to see a really good example of that here in a bit. We all know that the work that Esri does is we do fantastic work with spatial analysis, and that's been our bread and butter for years. And as GIS professionals, that's probably your comfort zone. Some of the examples that I have on this graphic depict things that you're comfortable with. Whether you know it or not, you're all probably pretty good at data engineering, taking data sets and manipulating. This was demonstrated superbly by Ryan from Tech Barnett in our first presentation, how he was able to take that data, do quite a bit of engineering using a tool like FME, and get that into a consumable, digestible way that made an impact. You saw the same thing with Tinson and Morgan with Repsol. They had to do quite a bit of data engineering. And of course, visualization and exploration is a critical component of that, demonstrated in both of those presentations. Then the spatial analysis suite is significant. And you see some of the buzzwords that are up here, some of the ones that I've mentioned earlier: predictive modeling, spatial statistics, image classifications. These are all the tools that you're going to use to support the problems you're trying to solve. And now we're seeing what's on the right side of this come into play so much more: machine learning and artificial intelligence. We're going to see an example of that here in just a bit. Big data analytics. You started to see that with Scott Newlis's presentation a moment ago on how we're ingesting what could be a massive amount of information from your mobile workforce as they move around the field and actually do an analytic on that in near real time to tell you something. That's big data analytics. And a lot of that is supported through modeling and scripting in Jupyter Notebooks, which are some amazing capabilities that you've had for quite a while, and you absolutely have people in your organization supporting. So these are the ways that we solve our problems and advance the work that we're doing. And you're about to see a really good presentation from my good friends at Apache, Casey Srivinka and Carlos Sosa, on how they have kind of figured out how to put all these pieces and parts together, and they do a fantastic job of explaining that. But they've really tackled a complex problem and put together a very creative solution that, I'll remind you, was a partnership by an IT champion, a business champion, and their peers at Apache that supported them through solving and capitalizing on value-directed operations. Casey, take it away.
Hello everyone, my name is Casey Srivinka. I'm a digital technology professional and ProdOps SME here at Apache Corporation with nearly 20 years of experience in the oil and gas industry. I'm here to talk to you today about an industry-wide challenge and how we are overcoming it with the help of Esri. Early last year, the world as we knew it began to change. Our country commenced going into lockdown in an effort to combat the spread of the COVID-19 virus. Apache in turn began immediately requiring mandatory quarantines for employees that have been potentially exposed to the virus. This quickly escalated into a shortage of frontline personnel, placing a strain on our ability to cover the inspections and service of our assets. In addition to that strain, the drop in commodity prices in the height of the pandemic prevented our ability to attribute more resources to support our field assets. This became our challenge. How could we responsibly cover our field operations? How do we safeguard our processes to ensure that our asset gets the attention it needs? What tools do we already have that can be used to solve this challenge? Enter project value-directed pumping. With joint collaboration between our GIS, development, infrastructure, and production operation teams, we created a project called value-directed pumping. Our core concept was to distribute a specific list of assets, now called stops, to every operator daily, identifying the key stops that need to be visited. These stops are ranked based on a comprehensive set of business rules regarding their respective risk levels, production potential, and inherent safety concerns. That ranking of assets would then be sent to, processed, and tracked by Esri systems, returning an optimized list based on time, priority, and value that is distributed to the field. My friend and colleague Carlos Sosa is now zealously waiting to tell you how we did just that. Carlos?
Thank you, Casey. Hi, my name is Carlos Sosa, and I am the GIS Platform Supervisor at Apache Corporation. Thank you for joining us today. I want to share with you our story on how we use the real-time GIS and routing capabilities of the Arcgis platforms in the Bdp project. We had mainly two requirements for this project. The first was to provide an automated way of monitoring the field activity, and the second requirement was to create an optimal daily route for pumpers based on values provided by Bdp prioritization service. With these requirements in mind, we came up with the following solution. This diagram shows the Bdp GIS components. There are mainly three high-level components: data, GIS platform, and microservices. The data sources we use are the facility geofences, the vehicle tracking, and the Apache road network. Our production Arcgis platform is on 10.6.1 on a standard availability configuration. We specifically use the Arcgis real-time components for this project. If you're not familiar, that is Arcgis Enterprise plus GeoEvent Server plus Spatial Temporal Data Store. The microservices are REST web services exposed as integration points for Bdp. Let's talk about how the microservices work. The field activity microservices are a collection of feature services that contains all the activity in the field in real time. The activity is recorded using the facility geofences as geographic boundaries. The purple circle in this illustration, when a vehicle enters the boundary or geofence, there is an event recorded that is called enter event. Then when the vehicle exits the boundary, there is another event recorded that is called the exit event. The duration on site can be calculated using deltas in these two events. The feature services are exposed as REST APIs for integration with Bdp. The routing microservices gets the list of facilities to be visited for the day from the Bdp prioritization module. It uses the vehicle routing problem analysis, or BRP, to resolve optimal route for each vehicle using Apache Road Network. Apache Road Network is built by using Street Premium plus Apache Lease Roads. This microservice is exposed as geoprocessing service using REST API for integration with Bdp. The Bdp concept was running as a pilot for one area in the field for months before COVID. With all the knowledge we acquired during this time, we were able to identify the challenges to move to the next big step, taking the pilot to production, or as the production efficiency team refers, industrialization of Bdp. In other words, making Bdp an enterprise solution. Next, I will talk about the challenges that we discover on each of these components. The data challenges. The data challenges we discover: how do we go from 800 geofences to more than 16,000 without hiring an army of analysts? Or how do we go from 200 to almost 3,000 custom roads? During the pilot, we were editing roads in an orthodox way, and this was causing road network failures. Also, Streetmap Premium updates merging was a little painful. We really needed a way to streamline the editing process. The solution: the data analytics team created a module called ZIBAG, which stands for Satellite Imagery Based Auto Geofencing. This module captures satellite imagery data and runs a series of computer vision algorithms to build geofence polygons around target locations based on their visual attributes. The output of this module is GeoJSON polygons, which are then ingested by FME tool to create polygons features on the Enterprise Geo database. Once the geofences polygons are created, the remote operations center operators can manually tweak to correct specs using an editable web map. Now, creating new roads. In order to find these missing roads in the network, we simulated all field routes using related facility locations at stops with Streetmap Premium. If any of the facilities fail to route, more likely there are no roads connecting that location with the road network. If that is the case, we need to create a new custom road to reach that location. All custom roads are managed into Apache List Road geodatabase. Streamlining the editing process. We engage Esri consulting services to get best practices for editing our own Apache road network. Following the recommendations, we have streamlined the editing process, and now it's more efficient to create additional custom list roads. Our custom roads are now close to 3,000. This diagram shows the editing workflow for Apache road network. On the left side, we have the ArcGIS Premium subscription, which is quarterly delivered via USB drive. Apache List Road, where we'll keep all our custom roads that later will be merged with Streetmap Premium. Apache Roadblocks is where we keep areas we want to exclude from routing. This can be hazardous roads, private roads, and potentially this can be during flood events. GIS platform challenges. In the GIS platform, we found the following problems. The number of resources we used for pilot was taking the platform almost to full capacity. We had some stability issues with other vehicle tracking input connector that read from GeoTab. We discovered missing data points and often will not read the service properly. We found stabilization issues on the platform on the real-time GIS components, specifically with GeoEvent Server. Our GIS platform was targeting office hours and not really field operation hours. The solution? In order to address the capacity issue in our GIS platform, we engaged Esri Solution Architect to help us with assessment of capacity and explore the high availability configuration option. After working session with Esri Architect, we concluded we needed to stand up a parallel environment with latest 10.8.1 version on HA with resource size based on load calculations. We solved the stabilization issue on the vehicle tracking by replacing our custom GeoTab net proxy service with Esri GeoTab connector. Esri GeoTab connector is configurable, supported by Esri, and the developer is very responsive. In addition to HA configuration, we work with IT infrastructure team to create a special ArcGIS IT maintenance window for patching, rebooting in the proper order. This schedule doesn't affect the field data collection hours. We also set up ArcGIS Monitor and other custom Python scripts to monitor services during field operation hours that will send notifications in case of issues. This is how the new Apache real-time GIS platform typical ArcGIS high availability configuration. All servers have redundancy, and the load balancer will reroute incoming requests if one of the servers is down. Microservices challenge, the routing microservice. The original routing services was running on schedule every day, one route at a time. The integration with Bdp was through CSV files mainly. It was taking about 10 minutes to execute a route. This approach was definitely not scalable. The solution? We made design changes to rerouting service by migrating from on-schedule to on-demand using a geoprocessing service. The geoprocessing service allowed you to use JSON to integrate instead of CSV files. We also performed some enhancements on the exception management, login, and the logic to read and write data. One of the other changes that speed up the routing was to host the road network file geodatabase locally in the server instead of a network folder. All the changes, the total routing exception time went down from 10 minutes to about a minute. In conclusion, we have used ArcGIS technology to provide field operation with a robust set of microservices that are easy to support and easy to integrate with our value-directed pumping project. Thanks for listening, and I hope this information was useful. Now back to you, Casey. Thank you.
Thanks, Carlos. Value-directed pumping based on the integrated technologies has yielded better results than we could have ever expected. To date, we can report that our operators are able to cover over 200% greater area responsibility, helping us cover those stops when resources are low. Of the stops they need to make for the day, they can now spend 40% more time on location doing what matters most, preventive maintenance work, tackling work projects, and production optimization. Even more remarkably, we've seen over a 30% reduction in drive time. Driving, which is our most dangerous thing we do day to day. The value gained from just one life saved from a driving incident is priceless. This project is still young and constantly evolving. Using the latest technologies, complex thinking, and partnering with companies like Esri, we expect much more value to come. Thank you.
Wow. Carlos, Casey, thank you so much. I think we're going to have quite a few questions to get to here at our live question and answer in just a little bit. But gosh, there's so much to summarize, and I'm actually looking forward to getting everybody together and chatting with all of you about the great work that's been presented today. But if I think about the takeaways, I do have a little bit of inside knowledge. I think one of the really interesting things is Casey and Carlos, when we first started visiting with you and preparing for the presentation, there was kind of a mantra that you had at Apache, and it was, every well, every day. And when that just couldn't really happen anymore, the old ways weren't the new ways, and you had to think outside the box. And Casey, I am interested to hear in a little bit on the Q&A, and we do have questions coming in already about this, so I'll give you a heads up on that. But how did you think about how you were going to leverage technology, and everybody's interested in how you brought Carlos into the mix, and how you guys thought outside the box to solve some pretty impressive numbers. I mean, doing more with less, that was one of the themes that we started with, right? A reduced footprint. And you guys were able to have 200% greater coverage with less resources by leveraging technology to help you. And then that led to some pretty important improvements. 40% more time on location, supporting things like preventive maintenance for your field staff, and then increasing safety. 30% reduction in drive time to reduce risk of your most dangerous task, which is driving. Those are some pretty big numbers, and I think you're going to get quite a few questions on that. One of the things that you obviously did is again, just like Ryan did, just like Tenson and Morgan did, you identified the problems and you discussed the potential solutions and how those technologies were going to support that. And Carlos, I can only imagine, I've known you for many, many years, that you had a deep bench of GIS knowledge, and I can only imagine all the different iterations and ideas that popped in your head and how to solve the problems that you did. But it's clear that that you piloted your way to success, and you talked about that initial pilot that you had, and I'm imagining that you were probably pretty strategic in how you did that pilot. You picking the right area, the right team of people to kind of help and work with you through developing what for them could have been a disruptive technology to improve the way they were working. So we'll talk about that here in a little bit. I also like the fact that consulting services was able to help you and help make a difference and help you get that deliverable out a little bit quicker. And then the fact that you mentioned Arcgis Monitor in your environment, and you were working with a high availability environment. So absolutely, you need a scalable, high performance, ready to roll environment that's going to support your work. So I'm glad to hear that Arcgis Monitor is a part of that. And first and foremost, this is going to be one of my questions for you, is you did an amazing job of capturing ROI, which to me says that you had to have had a really good indication of and understanding of the problems that you were trying to address, and that's a pretty fantastic story. So Carlos, Casey, thank you very much for sharing your story with us today. And as we wind down and move into our Q&A, thank you everybody from around the world that's been putting your questions into the chat box. We're going to get to them as quickly and as efficiently as we can. But at least on a parting word from me, we've seen some fantastic examples of petroleum organizations, your peers, that are addressing and overcoming significant challenges. And they're not only using technology, but they are leveraging location-based technology to solve those problems. But really at the heart of all this, and if we had one theme to really weave everything together, it goes down to understanding and communication. If that's the one thing I'd leave you with today, and it was evident in every presenter that we had today, that the technical leadership had a very good understanding of what problems they were trying to solve, And throughout that process, they were able to effectively communicate. And more importantly, they were effectively collaborating together. It wasn't one person's task or one person's job, or I'm going to go build this and this is how you're going to do it. It was a partnership and using science and technology and problem solving capabilities to pull this out. So really that's what geography is all about. And that's what GIS has been about for a long time. And the technology that you and the geospatial community and the petroleum user group community all over the world contributes to this is essential. And it's something that we've been doing very, as a group, the PUG has been doing very well for a long time. And we certainly appreciate you joining us today. This is only the first session of many over the next couple days. And we have fantastic presenters that I encourage you to listen into and join and participate in those presentations. So with that, this would be a fantastic time for us to transition over to our live Q&A, where we're going to be joined live from Houston and Fort Worth and Calgary from all of our presenters that you heard from today. So Mike and folks in the back office there, if you want to switch us over to the presenter view, Brady Bunch view, I call it, you'll see all of our faces and we can start to work through some questions. All right, so everybody on the other end, we're all live, and Ryan, Casey, Scott Newless, Tenson, Morgan, Carlos, thank you all for your fantastic presentations. Everybody can, if you start talking, everybody can hear you and they can see you. And we have some questions we're going to certainly get to. And Scott Newless, I'm going to rely on you to help me out with the questions a little bit. But one of the things that I wanted to start off with is, first, thank you very much for the excellent presentations. And of course, at Esri, we know that that's a big thing. You guys have busy jobs, things going on all day. So we thank you for sharing your story and putting the time in preparing that. Any comments from any of you before we get into our Q&A? This is my warm up for you. There you go, Tenson. All right, I knew I could count on you, Tenson. Oh, you might be muted there, Tenson. That's a good. You're helping us all out to make sure we're not muted when we talk. Oh, nope, you're still muted. Morgan, are you there? Is everybody, can you talk, say something?
I can hear you. Can you
hear
me?
Good, Casey, thank you.
Good deal. I'd like to say y'all guys did a great job putting all these presentations together for us. It's really great to hear what these, these other guys had to had been working on. So I think we even got takeaways from this, looking at some of the new velocity type technologies and stuff that y'all guys have that we're going to be looking into shortly. So yeah, that was great.
Yeah. Thank you, Casey. Ryan, you there? Is your mic working?
I'm here.
All right, Ryan. Well, Ryan, since you went first right out of the gate with your presentation on visualization, one of the things that it's been a reoccurring question, I'm scrolling through all the questions as Scott posts them in here, is how on earth did you figure out how to do that? in your diagram, you had the old pin diagram. Was this did you just dream this up and put this together? How did
I had been thinking for a long time about ways to try to visualize production over time. And, I explored other paths, like trying to do animations in a web map. And I was never quite, satisfied with being able to get the full picture of, a time span. And that's when, it started getting me to thinking about things that I've seen in the past. And I mentioned the chart recorders. And so that, ages ago, 1990s, I worked for a company that was a construction company building natural gas pipelines. And so I knew these chart recorders were around. I had seen the results of them. They were always interesting to me. It helped to be able to see something over time. And so I started thinking about ways that I might be able to plot out that production in a similar fashion.
Yep. Some of the questions, Ryan, And I'll just scroll through a couple. And Scott, if you see some, jump in. But I'll go with the bottom first, Ryan. But someone asked, was well spacing something that you considered to add to your visual, since this could influence performance of that well?
Well spacing, I did consider it in the process when I was sizing the charts, but no, I didn't think of it as something to be added to the visualization. There's some variabilities. In some areas that might work well, where the wells are running parallel to one another. In other places, not so much. They might be approaching each other at different angles. So it becomes challenging to specify a standard spacing.
Yeah. One of the questions also, Ryan, for you, and then we'll move on to some of the other folks here. But they ask, what FME tools did you use to process the data into the chart format?
Yes, that was probably one of the most complex workflows that I've put together, and there's a lot of transformers in there. But probably the one that they're most interested in hearing about, which I think of as the make or break sort of transformer that I had available, was the offsetter in polar coordinate mode. Without that transformer, I don't know how I would have accomplished this without probably having to get into Python to do some of the work. But
Yeah.
this was done no code.
I was surprised, Ryan. I was actually expecting someone to ask, "Hey, Ryan, can you share your workflows and models so that we can use them?" I haven't seen that yet, but I was expecting that. Scott, anything or anybody else have any questions or thoughts about the visuals that Ryan had in there?
Yeah, I've got something. Ryan, do you have any insight as to how some of these kind of custom visualizations that you were able to come up with helped kind of drive adoption across the organization? Did you find more people kind of gravitating towards these web maps and coming to you and saying, "Hey, what else? What other kinds of visualizations can you add?"
Yeah, I would say that when you can come up with a good focused solution to a problem, and it's saving somebody else some time. There's always other ways for people to get at data. There's other platforms, there's other sources. But when you can put it all together in one place in a very focused way and save someone time, it does drive a lot of traffic to the website.
Awesome.
Thanks, Ryan. All right, Mr. Morgan, Tenzin, you guys are on deck. There's a few questions here for you. Morgan, you're called out with this first one, and someone is asking what geo event connector you use to pull from Signet SCADA. Any insight there? Uh-oh, you might be muted, Morgan. Nope. Tenzin, you're there, right? No, we can't hear either of you. Uh-oh. Well, I'll come back to you. There must be something going on from Canada here. All right, so we'll get you guys to figure that out. So Carlos, Casey, that then comes back to you, and I'm gonna be selfish here. And Casey, I was gonna ask you a question about the ROI. It's just the numbers that you were able to provide and the percentages of that increase from the kind of the before and after. How did you put all that stuff together? And I'm assuming you did some kind of analysis before and could directly compare. Anything you can elaborate on?
Yeah, so we knew right off the bat, right, this project was going to be a little different than traditional projects when it comes to operations. We wasn't going to be able to look just at, did our production go up and things like that. Just easy, real quantitative numbers to go by, right? This is qualitative data. We're basically trying to see how long people are staying, on location, their quality of life, how things like that really have changed. But luckily, like the drive time was an easy one, right? Because we did have historical data from our telematic devices. So we was able to capture that for years prior while we've been using those devices and basically build a baseline. So we would know exactly how much time our guys was generally spending on location. this was before we actually had geofences and stuff. So there was a lot of manual work to go in to build this baseline. A lot of people going and looking at a lot of maps, looking at a lot of data and calculating that type of information. But now moving forward, now that we actually captured those enter and exit event times, like Carlos was talking about in the demonstration, now we can compare those apples to apples. We can see the gains on that. So by not doing this every well every day, which, like you said, was our mantra for the longest time, getting away from that and saying, hey, you know what, we don't have to visit these wells every day, but we can visit them on this set amount of time. And by doing that, we don't have to go to so many things a day. That really let us capitalize on how much time we were able to spend on location. And by doing that, we could actually cover more stuff, right? Because we don't have to go to certain wells every day. We might go to them every week or every 3 days or something. So that allowed our responsibility pool per pumper to really skyrocket. So that really helped us during COVID, when we had our area operation managers calling saying, hey, I've got 5 guys out of this area that, they can't work for 14 days. Now we have 3 left. Thank goodness for VDP. We was able to say, okay, it's all right. We can, running our conformance models, it looks like we could still be able to handle these wells at these set cadences and still match our business value and make sure that we're not letting anything fall through the cracks, and we're not doing, anything that's outside of the our norms of operation. We wouldn't, we're not going to break any rules, and we're not going to, cause any HSE events, anything like that. We're watching that, really closely.
Yeah, that's interesting, Carlos and Casey, that you guys were doing all this kind of right in the middle of the pandemic, right? Everyone's kind of dispersed, working from home, kind of trying to figure things out. What challenges did you have as a rollout to try to do this? Was the pilot going on still at this point? And how did you, I'm guessing this was a disruptive technology for the folks that you were introducing it to. Any challenges that popped up with that?
Sure. So, like I said, this was a major culture shift for Apache, right? These guys, they was hired and told the day one. Even when I started at Apache as a pumper, the first thing I was told from my foreman was, we go to every well every day. This is a deep rooted culture, right? The way we've always done it. That drives culture. That's what you always hear. So we had to spend a lot of time. We spent a lot of time building this tool with our guys from the ground up. So every concept, every part of our business rules, and every way that we was wanting to programmatically handle this, we made sure that the field was constantly involved and constantly took their feedback. So we took these original pilot areas that we was working with. We took the lessons learned from that, and we actually, in the response for this, COVID and everything else, we kind of chopped down our original pilot to be able to scale quickly. We took out some more complicated components, and we made this to where we can move really fast. But we visited every single field area. At the time, it was 29 foreman areas. We're talking hundreds of pumpers. We spoke with them each one-on-one and in a group setting, and gathered their feedback and made sure they really felt like they was, part of this development. This was really an Apache-driven and Apache-developed project, all the way from the frontline workers to our very capable IT teams that we have.
Fantastic. Carlos, there's a question here for you that I think maybe picks up where Casey just left off, and it says, once you decided to make the solution, quote unquote, production ready, how long did it take you to fully roll it out to the business?
It took months. I want to say, Casey, correct me if I'm wrong. I want to say it took about 6 months to take it into production, because we were taking area by area, and like Casey said, it was a process, right? So Casey will travel to different field operations. He will sit down with the people in groups and all that to talk about the project. And then at the same time, I was working with all the GIS analysts to get the data ready, basically, all the road network, all the geofences. So everything was happening at the same time. So wow. So when Casey was ready to roll out, most of the times, I want to say, we actually had the data ready so we can keep moving and implementing it.
How many folks, Carlos, from your side were working on this from an IT GIS side? How many people did you have doing this project?
think I want to say, I mean, some of you are hopefully attending the conference. I want to say we were total about 5 analysts, GIS analysts, between supervisors and analysts, about 5 or 6 people.
Fantastic. And I know Scott Nolis's dogs bark after a year. Scott, is that yours? Was that your dog, Scott?
Yeah, I was trying to mute my mic.
All right. Well, your dog wanted to be broadcast live around the world, and speaking from live and around the world, Morgan, can we hear you now from Canada?
Yeah, can you hear me now?
Oh, look at that. We fixed Canada. Morgan.
Canada.
All right. Well, we'll come back around for some questions. Ryan, don't go anywhere because there's still some questions for you. We're trying to disperse them out so everybody gets a good dose of talking time. But Morgan, there's a couple questions, and the one that I was trying to ask you before was all about the GeoEvent connector that you were using for the SIGNET and SCADA information. Can you talk a little bit about that?
Yeah, I mean, unfortunately, that's actually the part of the project that was more Tenzin. So Tenzin, it was kind of Tenzin's creation, and he was kind of working with our team in Madrid, the IT GIS team there. So they were kind of organizing all that. It took a while, like a year or so. I can't speak to the exact connectors, but I know he did a lot of work. Like, I was sitting next. I was in the next office over from him, and he had, like, I want to say, like 50 different meetings, just trying to orchestrate everyone and bringing up his wall of awesomeness and just having people parading into his office pretty much. So I can definitely speak to how much fun, I guess, he had kind of orchestrating the whole thing. But yeah, my role was more, once it was kind of connected and mashing up all their data sources into the portal, kind of support, a bit of a support model at the end too. Triaging different issues from the end users, from the IOC, and just making sure the system runs smoothly now if there's any kind of glitches. So, Tenzin's back here. Maybe he can.
I know. Speaking of Tenzin, I bet you anything we fixed him too, right, Tenzin? You there?
I think, yeah. Can you guys hear me all right?
Oh,
Yeah.
We got you crystal clear, Tenzin.
Perfect.
Morgan was just covering for you while we got you resolved on the back end there. And we were going back to that question about the SIGNET connectors and kind of how you brought all that together. And Morgan was telling us that you had maybe that's where the wall of awesomeness came from. I don't know, but he said all of your ideas were scattered amongst your wall as you tried to figure that out.
Yeah. So as I mentioned to you guys earlier, there was a whole shift in terms of moving our GIS platform from Canada over to Madrid. That in itself created its own little situation where we didn't really understand exactly what was going to be where and how things were going to connect, and if we could even connect from one country to another country and push this data back and forth. And at the same time, our instrumentation teams are going through some changes as well, and selecting new applications and software to use for their purposes, their own internal purposes. So what we did as a GIS team was try to understand what the landscape looked like infrastructure-wise as well as software, and then said, okay, what is the most cost-effective way to utilize what we already have, to then connect our systems to whatever GIS system, wherever that GIS system is going to be. So that was the issue, and we had to involve our IT security teams, our risk teams, we had to look at their information management governance, and make sure we can access this data back and forth. We had a lot of different teams kind of advising us one way or another, and we kind of ended up sticking with a software called OSI Pi. It was selected because it, at the time, was one of the tools that we had available currently that could support the real-time data push to GeoEvent. So in between SIGNET and GIS was our OSI Pi system.
Nice. Thank you for sharing, Tenzin. Definitely sounds like a lot of moving pieces and parts there. But we've had a couple questions around the applications that you used. Morgan, you demonstrated, web app builder, so you had some configurable apps. You showed some dashboards, and you talked about workforce as well. And one of the questions here addressed to both of you is, are you using Workforce in conjunction with a work order management system on the back end?
Yeah, I can speak to that quickly, and then maybe Tenzin can add. But again, yeah, we are just in the process now of switching work order management systems into SAP. So that has been requested by the IOC operators. It'll be a big value add once we can get there. But yeah, again, there's a lot of moving parts right now in our organization, and so we're kind of holding tight on that for now. But yeah, it's definitely been requested.
Yeah, same thing as Morgan said. It's part of our. It was part of the scope that we developed. We had a 3-phase scope. We finished with our scope 1 phase, phase 1 of our scope, and that was just to provide a minimal viable product to our clients. Phase 2 and phase 3 are all the extra things that they wanted to do, and part of phase 2, I believe, was to try to connect it to our maintenance systems because they do ticketing through those systems. But we also found other, ad hoc ways that people were trying to maintain maintenance schedules and logs, right? Because there's sometimes that system wasn't adequate enough for their purposes. So we just said, okay, well, before we try to delve into that and start to detangle that, let's just provide them what we can already provide them out of the box, and then work on that in the future when those systems are up and running and in place.
Thanks, Tenzin.
Hey, Adam,
Carlos,
sorry, I cut you off.
Go for it.
So you mentioned Web App Builder, and Morgan, you showed a couple of different applications. So you showed a really cool widget in there, the incident analysis widget, where you could kind of drop a point, set a buffer, and get some different things about weather and the assets impacted. You want to talk a little bit about kind of what it took to set that up, kind of what was included out of the box, and kind of how your guys in Operations Center use that?
Yeah, so I mean, I'd like to make myself seem super smart here, but I mean, Esri's done such a good job of these apps. I was actually, I remember I was kind of just playing around with some of the different widgets, and I was quite amazed when I found it. I was like, oh, this is so easy. It's just like configuring, and then again, it's kind of goes back to Tenzin's thing where you have to kind of walk the halls and see who's interested in this, because some people really don't care depending on the department. But then our emergency response team, we were able to bring that up in live events and kind of drills, and they're really impressed with just seeing like the live weather pop up and just what residents are going to be affected in that specific buffer. So yeah, it's actually quite easy to set up, and the whole Esri web app builder and all that's really making us look really good. So thanks a lot, Adam.
Well, that's one of the things I build, Morgan.
Yeah.
So yeah, I'll take all the credit there. Unlike you, good job. Oh, Scott's going to give me a hard time on that. Carlos, there is a question. Go ahead.
Oh, sorry, Adam. I was just going to add, one of the best things that I find about the Esri product suite was that the capabilities, the applications allow for cross-functional capabilities. So like being able to build a form, then that form being able to be accessed through a collector or field maps, I guess is the new one, and then being able to show that back on in the office on our screens in real time. The status of that inspection. Not having to think about how the data moves across from one system to another system in that really helps to showcase what we can do as a GIS team. Because a lot of times you get to the one point and you're stuck and you got to wait for IT to help you to connect something to another thing, and sometimes that doesn't work out well. So it's nice to have that ecosystem already kind of set up that it can go across systems, and that just enables even more. That's the wall of awesomeness, I think, that the guys were talking about, is everything's all connected together. We just have to figure out what we want it to do. So that's
all right,
that.
So here's my idea, Tenzin. This is what we need to do. This is our opportunity. We've got to create, at the next Esri user conference, perhaps the Petroleum GIS conference next year in Houston, we're going to have t-shirts made, Wall of Awesomeness, and we're going to have a little booth where you can sign that. We're doing that. That's the plan.
All right, sounds good.
Well, we've got a couple more questions just directed towards some folks individually, and then I'd like, as we kind of wind down in the next 9 minutes here, I do have an open question for all of you to kind of cap us back. But before we get to that, Carlos, this was one that was directed for you that is in our queue here. They asked, Carlos, how much ground truthing was done on the auto geofences, and what was the process for determined accuracy level?
So after we ran the side-back process, I think roughly we got about 80% of the way there, and then we got the remote operations center operators. They were matching the outlines with satellite imagery, basically. So that's the level of accuracy. I mean, and of course, this is an ongoing process, right? Because we're still finding some tweaks here and there. I mean, every week there's some process of readjusting a little bit, because as some of the operators, some of the pumpers, sometimes they will say, well, I didn't get credit for that visit. Well, then we go back and check. Oh, okay, so you didn't need credit because the shape of the geofence is not quite right. So we have to, modify it a little bit. So it's basically an ongoing process.
Fantastic. Scott, we have any more questions before we kind of do our sign-off question here in a little bit and give everyone a chance to speak?
Yeah, Ryan, we just had one more for you pop up. So you showed obviously a lot of processing being done in FME. Could you speak to maybe some of that, or what parts of that could maybe be done inside of SQL, within the database, or does it require something like a specialized tool like FME?
There is a mixture going on within the FME workspace itself. So, our production history is pretty extensive, goes back many years, but what we're showing is just a year. So it starts off with an SQL executor that queries the past 365 days worth of production to sort of limit that data set. So it's all done within the FME workspace.
Thanks, Ryan. Well, I've got a sign-off question. So we've got a few minutes left, and I'll give each of you an opportunity to share your thoughts on this. But what was really apparent to me as we interviewed and visited with you over the past few weeks preparing for this live event, one of the things that was apparent to me was the common thread that weaved through every one of your presentations. So not only did you have very creative, great ways of applying the technology to solve a problem, but in every one of your stories, and I meant it, I said this whenever I was kind of doing my guided talk into your presentations, there was a theme of understanding. So you had to have understood the problems that you were trying to solve. And then there was very good collaboration and communication. And to me, it seems like, you always hear the saying that the biggest problems to solve are always people problems, right? Technology is the easy part. I don't know if you all find that true, but I'm wondering if maybe we can go around the Brady Bunch window here, maybe Ryan, starting with you, and tell us a little bit about your thoughts. Like, how did communication, collaboration, how did that all come to work for you, and what was that like?
Taking the example that I gave, it started off as a pet project that, it reached a certain point and I put it aside. But it was like a year later, having discussions with my coworkers about it, sort of brought this back, into my mind. And, we were all talking about the best way or a better way to see the production over time. And that kind of spurred on, the further development of that process.
Thanks, Ryan. Carlos, well, Scott, do you have anything to continue there? I don't know. I don't know what I put you on the spot, Scott, as the Esri guy.
Yeah, no, I think what was evident in all of these presentations was again, that location is a critical component, whether you're looking at production values or you're looking at real-time, readings coming off the wellhead. And there's a bunch of different out-of-the-box tools, right, that you can leverage to create visualizations or share data with people in the field. So, although there's a lot of really cool custom things that you can do, there's also a lot of great things out of the box that you can kind of tackle as low-hanging fruit right off the bat.
Carlos, any thoughts?
Yes, I think going to your comment on collaboration, I think that was probably the most difficult part for this project for me personally, because when just in the middle of the project, there was a massive IT reorganization, so the whole GIS team got disbanded and ended up in different application teams and infrastructure teams and all that. So it was challenging to coordinate all those teams together, right? Because I have to talk to my new infrastructure team, right, to ask for resources. Hey, I need more servers. I need configuration of all the NetScaler and all that. And then I have to talk to application team, kind of borrow some of the analysts from the infrastructure team to support the desktop and so forth, right? So it was challenging, but I think it really turns out great. Everybody was key in the success of this, and especially working with Casey, it was really good. As you know, Casey. So we've been working together for years. So it was, all in all, I think collaboration was the key for this project, at least from my point of view.
Casey, he's saying good things about you. What would you add?
Yeah, I appreciate that, Carlos. No, so building on what he was saying, communication is key, right? So especially when you're dealing with operations in general, as you know, in our industry, we have all this technology being thrown at us. We have all these great things we can do now, right, inside our IT and GIS departments, and we want to get it to our frontline fields. But if we don't communicate what we're doing, and how we're doing it and get their feedback, that closed loop feedback is just key to making any of these projects work, right? We're putting these tools in the hands of people, engineers, frontline operators, supervisors, things like that. These guys, they need to be a part of this team. We need to make sure that we get their feedback. We build our tools based off their needs, right? What problem are we trying to solve? Like you just said, that's always, I think that goes for every company. I think everybody has this same thing, right? What problem are we trying to solve? So make sure that, at least from our standpoint, we made sure that we was addressing all of our field needs. Those guys was at the table constantly, either as me being a liaison between operations to IT, or bringing guys directly into the table in some of our technical meetings and having them state their user story or their persona, what they had going on in the field, and then taking that and crafting this tool to match their operations. But there was so much communication between all teams, between the operations side with the IT side. That's what made this project successful. And I think that's what makes any project successful.
Thank you. Well, Morgan and Tencent, I'll lump you guys together because we're like in a minute before we're over. Any final thoughts or comments from the two of you?
I'll just quickly say that, in terms of collaboration, once you have your end product, it's super important to kind of see who else is out there that could use that output that you spent so much time creating, like in our instance, using the IOC real-time data for the emergency response planning or our pipeline, geometrically connected pipeline network. So just you've done all the hard work, and then it's good to collaborate and see who else could use your output.
And I just add, Adam, I think you talked about it earlier about me walking around the hallways. I'm not aimlessly walking around the hallway. I go to people, I deliver my maps or my solutions to them. But I then, I was actually talking to the construction foreman at the time, and I just provided some hard copy maps for him. And, I said, hey, I got this new tool, kind of shows you where you are on the map, and you can pull up some stuff. And he's like, well, I don't really need that for myself, but there's a guy over there that may be interested in it. You should go talk to him. And, I'm like, okay. And I just walked over there. I didn't know the guy. I just knocked on his door. I'm like, hey, Roger, can I come in and show you something? And sometimes, people like I've mentioned this before. Sometimes you don't know what you don't know, and you just and for good or for bad, sometimes you only scratch the surface of something. But even just scratching the surface of something is something rather than nothing for that person. So I showed that user Workforce, and my phone turned on, showing my location on that map, and then I put a couple of assets on that map, and I just showed that to them, and there was nothing else fancy about it. It was just, hey, look, I can track myself on this thing, and the business client was just amazed by that. It's like, wow, I didn't know we even had that capability. So sometimes it's good to just even scratch the surface and just show them what you can do, and that'll evolve that conversation even further.
It's great inspiration and vision and comments. Thank you all for that. And we're a little bit over, but I couldn't thank all of you enough for the fantastic stories and your organizations for allowing you to share those stories with the global community that's watching us live right now. So thank you all from the bottom of my heart and everybody at Esri. We greatly appreciate your time and your effort in joining us today live, and we couldn't thank you enough. So Mike and everybody on the back end, I think we're wrapping it up here. Thank you very much. Thank you for joining the operations session today. Everybody have a wonderful day.
Great, thank you.
Thanks.
Everyone.